Segment 55, Dark Matter and Dark Energy. We can see the universe, as we mentioned in the last segment, as really consisting of four epochs. The inflation-dominated universe, when this runaway growth of the universe, when it was in a tiny fraction of a second, put together the geometry of the universe as we know it now. Then the radiation-dominated universe, where very, very high energies were involved, and radiation was the major form of all the material in the universe. And then the universe of dark matter, where the mutual gravitational influence of dark matter dominated the way the structure of the universe evolved. And then finally, the era that we live in now, which is the dark energy dominated universe. In all this, you notice I didn't mention the universe that we live in, the baryonic universe, the universe made up of atoms and molecules, which only account for about 4% of all the material. Basically, we're all just along for the ride through all of these epochs. At no epoch did this material actually matter in how the universe evolved. It matters a lot in how it appears, but not in how it evolved. I mentioned this in the last segment. But theoretical models follow the expanding universe by taking into account the actions of gravity on dark matter, and they can only account for the current structure of the universe if about 40% of the universe is made up of dark matter. If this cold dark matter that interacts with itself under the influence of gravity and is moving relatively slowly, can have an effect and can cause this structure to grow. So I want to talk a bit about the dark matter in galaxies, dark matter in clusters, and then dark matter in the universe as a whole. We talked a few segments ago about the evidence for dark matter in galaxies, namely that if you look at the rotation curve, the velocity versus distance in a galaxy, that instead of dropping off as you might expect based on the stars that we see and figuring on the mass of the stars, that the curves are flat out to long distance, implying that there's additional matter that we're not seeing on the larger scales in the galaxy that keeps the rotation curve velocity from dropping off as you go out. And this is a halo of dark matter, a more broadly distributed dark matter distribution in the galaxies that comes to dominate the mass as you go to the largest sizes. If you look at a cluster of galaxies, the evidence for dark matter comes from the velocities of the individual galaxies. If you add up the mass of the galaxies, even including the dark matter mass of the galaxies from the rotation curves, and then you look at their individual velocities, the clusters should tear themselves apart. The galaxies should fly out and go off on their own over the course of the billions of years of cosmological time. But in fact, these galaxies are bound together. They're still in a very localized region of space. The only way that can be true is if the cluster itself contains a huge amount of dark matter that holds these galaxies bound together. And so that dynamical evidence is very concrete evidence for there being a large amount of dark matter distributed on the scale of the cluster of galaxies. Another piece of evidence for the existence of dark matter comes from general relativity. We discussed before the equivalence principle, the fact that you can't tell the difference between a stationary frame in a gravitational field and an accelerating frame with no field. And this equivalence principle leads to an observable phenomenon which was tested already a century ago by looking at the bending of light around the sun during a solar eclipse. And that is this phenomenon of the bending of light when the light passes by a massive object on its way to you, the distortion of light rays, which would normally travel in a straight line, because in fact they're traveling in a straight line, but the space around the massive object is curved, and so that line doesn't appear straight to us as we look at it. This acts like what we call a gravitational lens, something that can distort your vision of an image by bending the light as it comes to you. So the almost like a funhouse mirror. So the top illustration showing an example of the Smithsonian Castle on this effect. But we see this effect actually as we look at distant galaxies lensed by the massive material dark matter in clusters of galaxies or around massive galaxies that are closer to us. For example, objects like this, which is what is known as an Einstein ring, what you're seeing here is a relatively nearby galaxy with a very distant galaxy behind it, whose image is now being made into four parts by the focusing of the power of the dark matter in the foreground galaxy. Um, Here also we see an illustration of this in the form of these beautiful arcs that you see in the Abell cluster 2218. These arcs are actually distant galaxies that are being distorted as their image is propagated through the foreground cluster, where the huge amount of dark matter in there is bending the light and distorting the galaxies. This provides not only concrete evidence for the existence of dark matter, but with modeling efforts using the principles of general relativity, we can estimate how much dark matter is in a cluster like this and how that dark matter is distributed by looking at the shapes and distortions of the bent light. So gravitational lensing is a great tool for finding out about the existence of dark matter. Here's just a few more illustrations. Again, these blue galaxies that you're seeing on the right are lensed galaxies behind this cluster that you're seeing here in the foreground. And on the left, you're seeing, again, more of these Einstein lens type galaxies. The argument for dark energy is more complex, but the evidence is pretty solid. Now, we mentioned before the expansion rate history of the universe, but there are other pieces of evidence that come from studying the microwave background that help solidify this picture. We're not going to go into that, but I urge you to look at the videos that we're putting online about dark energy as well.